Okay, this is the graph characteristics part 2 of the quadratic for the next day. All right, this is our function. I put it into Desmos and graphed it and got all these points. This is our vertex. This is the y-intercept. And this is just another point of interest that I put over here just because it was right directly across from here just to get the shape of the bell curve. All right, now remember, we have infinity, infinity, negative infinity, and negative infinity. So when I label my arrows, this is my x, this is my y. Over here, this is my x, and this is my y. All right. Now, this one, remember when we label increase, decrease. Now, this is making you go all the way back to the very first test of the year where we were doing lines. So we are doing all these graph characteristics again. And remember, we labeled them all with the x. Just about everything gets labeled with x. Okay, so increase is going from negative infinity to 2. This graph is increasing all the way till we get here. Then it starts decreasing from 2 to infinity. This graph does not go above the x-axis, so none of it is positive. All of it is negative. So from negative infinity to infinity, it's all negative. In behavior, really remember, all you're doing is reading the arrows and plugging it in. So as x approaches infinity, which is this one, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. My axis of symmetry, y'all, that's a line right down. It's right there on the vertex. See that? The vertex is 2, negative 1. You label it with x. So it's the vertical line, x equals 2. And I just kind of sketched it a dash line. And that is a maximum point because it's the highest point of the graph. So 2, negative 1 is a maximum point. Got another one here. And again, I went into Desmos and graphed it, and so can you. Desmos is easy. You just plug it into Desmos and see what it is, and then we labeled everything. All right, so this is the point here, negative 4, 0. This is the point negative 2, 0. Forgot to label those. All right, so this is increasing from negative 3 to infinity. It is decreasing from negative infinity all the way to negative 3. It is positive. Now that's everything above the x-axis. So it is positive from negative infinity to negative 4. And then we say union, because we got more of it over here, negative 2 to infinity. It is negative from negative 4 to negative 2. So all this right here is negative, from negative 4 to negative 2. Again, read your arrows. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity. My axis of symmetry, again, right here, x equals negative 3. And that is a minimum point because it's the lowest point on the graph. Okay. Same exact graph from yesterday. We went into Desmos and we graphed this equation, and now we look at it. All right, and I want to make sure that I did real world when I did this, and I'm not sure. We'll look at it. Okay, this is increasing. The actual function is increasing from negative infinity all the way to 15 over 16. However, do we have negative infinity time? We don't. So that's theory, but what we're starting with is 0 because right here we have a y-intercept at 0, 4. You don't have negative time that you throw a volleyball or a soccer ball or whatever kind of ball it is. It's a volleyball. You're starting at 0 seconds and throwing it. So it is increasing from 0 to 15 over 16. And then it is decreasing from 15 over 16 to 2. I wondered if I did that right, and I did not. So it is decreasing from 15 over 16 all the way to 2 because we don't go down in the earth again with that volleyball. It It hits the ground and comes back up. It actually bounces back up. All right. So now that's decrease. So this is positive. Again, we're talking about real world. It is positive from 0 to 2. And I wrote -1/8. There is no -1/8 time. So it is positive from 0 to 2. Okay, it is negative from 2. Well, the ground, it's not, is it going to be negative if it's a volleyball? In real world, no, it's not. Okay, because there is no, it's not going to go below. Okay, the axis of symmetry is x equals that 15/16. And then the rate of change, okay, from 1 to 3. You have to evaluate this by plugging in 1. So if I plug in 1, I get -16 times 1 squared plus 30 times 1 plus 4. And that is going to give me 18. Okay. Then when I plug in 3, and that's what I'm doing, I'm just plugging those values in, I get this, and that gives me 130. Okay. Then rate of change is y2 minus y1 over x2 minus x1. So when I put in my y2, that's 130 minus 18 over 3 minus 1, that'll give me 56. And that is the rate of change. So that's 56 feet per, I'm sure it's second, 56 feet per second.